Hello students, a very warm welcome and good evening and a very warm welcome to JEE English Unacademy, India's leading and largest JEE test preparation platform. And guys, I'm really very sorry. My apologies for the delay. There was some technical issues, and hence it took a little bit of time. Never mind, we'll get into a very interesting lecture. It's going to be a super interesting lecture. And in today's lecture, you know what, we are going to solve, some JEE advanced problems. And you'll notice this is based on the concepts that we are going to discuss today. So that way, stay tuned. It's super interesting, guys. But at the same time, you know what? Try to understand each and every concept in this chapter. I've seen some JEE advanced problems. They're just based on concepts. I mean, like just based on concepts, and you could have scored them if you understood the basic concepts. All right, and also complete the previous lectures. Don't delay things. Keep taking down notes. Very important, guys. Very important. Electrostatics is something where you don't want to even miss a lecture. Don't even miss a lecture. And students, don't forget to share the link and click a like button, and also click on that subscribe button and bell notification. And that being said, students who know me well and good, if not, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I have filed, 25 patent applications in India and abroad. And students, do check out our Telegram channel to get timely notification. And students, make sure you keep watching our Telegram channel. Get onto our Telegram channel. First of all, you need to download Telegram app from Google Play Store or App Store. And then you need to click onto this link. This link is available in the description box below. And all you need to do is just click onto this link. You will be joining our channel, and on this awesome channel you will be getting timely live updates on whatever is happening on JEE English. Not only that, also our Unacademy special classes. You'll get information on our Unacademy special classes as well. So yes, don't forget to do that. Many DPPs as well. So do get on to our Telegram channel if you are not yet on it. And students, the thing is, we have started with capacitors, and we have completed units, dimensions and measurements. So this is going to be A to Z series of units, dimensions and measurements. If you have not completed it yet, do complete it, because this is easy, less time taking, and typically you can expect at least a couple of questions in your exam. And JEE Mains, JEE Advanced combined at least 2 questions. So guys, this is available on Unacademy learning app, and these are all back-to-back sessions. These are all back-to-back sessions plus an extra Sunday lecture, and you need to cover that as well, because different kind of model problems were covered in that was not covered on YouTube series. So do cover that lectures as well. For detailed lecture, you can check out YouTube links. And students, this is a free of cost special class. And capacitor second part, we already completed part 1. Second part will be happening this Sunday, so don't miss it out. And students, how do you attend the special class? All you need to do is download Unacademy learning app from your Google Play Store and App Store, and you'll just type in Unacademy and you'll be able to find us. This is the most downloaded education app, and then you'll click on the install. If you download the Unacademy learning app, not only you can attend special classes from anywhere, but you'll get timely notifications. So do download it. What are you waiting for? Just go ahead and click on that install button if you're already on the app. And not only that, you can attend free quizzes, and these quizzes have very interesting problem. Your PYQs, model problems that are typically asked in JEE Mains and JEE Advanced. And students, that being said, if you're looking for a champions tool for JEE Mains and JEE Advanced preparation, we have the best champions tool for you. And guys, what am I talking about? I'm talking about your Unacademy subscription. So this is an awesome platform, and in this awesome platform, you not only get access to daily interactive lectures with top-notch educators across the nation, but you can also get your doubts cleared from them, and more importantly, you will get access to a structured learning program. And in a structured learning program, you'll be attending multiple quizzes during the session. You'll be attending national level test series. And guys, this is the thing that you need to crack your JEE Mains and JEE Advanced. And always we maintain the completeness on this platform. So do check out, if you're already on Plus, don't hesitate to give tests. That is very important, and do check it out. You can also try out the trial, and all you need to do is click on the left hand top corner extension bar, choose Plus, and then choose IIT JEE as your goal, and then get the subscription. It's one subscription, unlimited access. That is it. And guys, you know what, you get many free of cost lectures, and I mean like complete free of cost lectures with complete information and quality lectures on JEE English. But you get the same thing over there, no, little bit more, because why little bit more? It's a very interactive platform. It's technologically equipped. You will be able to interact with me, and not only that, guys, you will get to attend, you will be able to solve questions along with me, and more model problems, structured learning. These are the prime differences, and that makes it, that really makes your journey very easy for getting into IITs and NITs and best educators across the nation. So I need not say that. And we also have legends like DC Pandey sir on this platform. And guys, the price is also affordable and economical. If you can afford it, this is the best thing that you can get. It's only going to cost you less than 70 rupees a day. It's 2,100 per month. And how do you get to this price point? Apply Murli Live coupon, students, and this is about 24-month subscription, typically meant for 11th class students, 10th class students, and 9th class students. So yes, so this is the best program for you. It's daily interactive classes, and moreover, we have pay in parts, payment feature for you. So this is our in-house feature which takes away the burden of paying all the fee at once. So yes, you may want to check out this pay in parts option. We also have no cost EMI, which also takes away the burden of paying all the fee at once. So these are like the two payment options that we give it for you, so that it takes away the burden of paying all the fee at once, and you can make use of also other traditional payment methods like debit card, credit card, UPI, etc. And guys, if you're looking for a 12-month subscription, so this would be typically for whom? Long-term dropout and 12th class students. Okay, we have dedicated programs for you. Yeah, it's going to be intensive and extensive program, so that's the thing as well. So maybe you want to start now, because this is the right time to begin. This is the correct time to begin, because you are right now in the in the time where the lecturers and the educators are hosting courses for your JEE Mains and JEE Advanced preparation. And guys, the cost is also very reasonable. It's only going to cost you less than 2,900, and you can apply Murli Live coupon to get the best discount on your subscription purchase. So do apply it and get the best discounts. Hi Divya, hi, good evening guys. So yes, and what else do we have? We have dedicated programs for long-term and dropouts. Not only that, we have 6,000 plus 7,000 plus materials for your JEE Mains and JEE Advanced preparation, and 600 plus live programs going on Plus. So do check it out. And students, recently launched Optics Basics to Advanced. We are yet to complete just plain mirrors, so start attending the lectures if you haven't yet started yet. Launched on 9th October, Optics Basics to Advanced. We have so far completed around 50 problems, 50 different model problems. Maybe you want to complete them as well. Okay, so yes, it was launched on 9th of October, so don't miss it out. Don't miss out on a single session. Enroll soon, and enroll with Murli Live coupon if you haven't yet subscribed yet. And if you're planning to subscribe, this is the time. And if you're on Plus, start enrolling to the program and start attending it. It's going to be super easy. Once we cross plain mirrors, then you need to be very, very regular to the lectures. And anyway, we have amazing, awesome students who can think innovatively, and that also makes an academy subscription really interesting. Very new perspectives, scientific minded students who come up with kind of new theories, etc. Easier methods to solve the problems. So that is the beauty of an academy subscription, and that is the beauty of this course as well. So you may want to attend this course, and it's going to be interesting. It's a full-fledged comprehensive course on wave optics and ray optics. So do attend it. And students, that being said, a very good evening. Remember, we are on electrostatics. Only one thing is going to help you: practice, practice, and practice. You must have heard this: practice, practice, and practice makes human perfect. And this is absolutely true in electrostatics, guys. Of course, understanding concepts, understanding theories, understanding many things. But a lot of math is involved when you're talking about electrostatics, math, etc. Electrostatics and mechanics. A lot of math is involved. Hence, you want to keep practicing to stay in the touch. This is true for any physics, for any subject that you're dealing with, but this is especially too much true for electrostatics. So keep practicing. You may know the concept really well, but this needs to click in the exam. For that, you need to practice. And if you remember, every charge has its individual field, and these fields are not affected by the other charge. So if I'm talking about charge Q1 would have its individual field E1, and that would not be affected by the field created by Q2 E2. And similarly, charge Q3 would have its individual field, which is not going to get affected by Q2 and Q3. Okay, so that way every charge has its own field, and what is field actually creates a force, like an electrostatic force on maybe any charge placed in its field, and every individual charge would have its own field. Okay, and typically how would you find out electric field? By adding the vectorial quantities like magnitude of electric field intensity. So same thing. And how do you find it out? You would find it out by adding the vector quantities of electric field. That's it, guys. That's it. It's a very simple concept. I know this is just a concept revision for you. If you haven't completed, previous lectures, do complete them. A lot of amazing visualizations. And yes, these are all vector quantities, so you will add it in the vector terms. KQ1 R1 square R1 cap, KQ2 R2 square R2 cap. In this case, don't worry about the sign. As soon as you substitute, so you can see this is a negative because the fields are flowing inside the charge, like towards the charge, whereas for Q1 and Q3 the field is flowing away from it. Hence, once you start substituting the value of Q2, you will typically, you're applying the sign convention. So don't worry about it. So once this is negative, this will go inside, And yes, the other one is going to be KQ3 by R3 cap. Everything, if you notice, there is an R1 cap attached to it, R2 cap attached to it, R3 cap attached to it, which denotes its position vector. And yes, net field is dependent upon the electric field generated or produced by each charge Q1, Q2 and Q3. Okay, now let's get into a very interesting thing. Try attempting it. So we have discussed fields, everything. Carefully try to attempt this problem. Okay, 3 positive charges are given to you. It is a JEE Advanced problem, very simple problem, of equal value Q, and are placed at the vertices of an equilateral triangle. The resulting lines of force should be sketched as it. Try to think very carefully, very carefully. What is given? 3 positive charges. Take your time, try to solve this problem. It's very simple, guys. Very simple. I'll tell you why this is very simple. A couple of options, all the options you can eliminate it just by having a look at it. All of them are positive charges. Okay, so take your time, it is fine, totally fine. But you know what, this is literally a 30 seconds problem. This is like a bagger. This is the thing that you can literally score very quickly. These are the kind of questions that you want to maybe even attempt first. If you're well off with the concept, only it's possible. So make sure you're understanding every single concept, you're attending every single lecture, you're not missing out anything, be it on JEE English or be it on Unacademy Plus. So that is something very important, guys. So missing out even one lecture can harm you. Alright, I'll give you 2 more minutes. Just think about it. It's quite easy, right? It's very easy. Apply the basic thing. This is solvable. Alright, let's get into it. First of all, let me remind you something. So this is a plus Q charge, and this is going to be a minus Q charge. How will the fields flow, guys? Okay, there will be many field lines. I'm just talking about one field line. It will flow from positive charge to negative charge. So closed loop can only be formed if there is a positive and negative charge. So 3 positive charges of equal value are placed at the vertices of an equilateral triangle. Some problems like what we solved yesterday, but they are now talking about field lines. We can't really sketch the field lines. We are not aware of it, but we can eliminate the options. Closed loop cannot be formed. Here, loop is flowing around positive charge. Here also there is a closed loop. Where did the closed loop come from? Closed loop cannot be formed. Alright, closed loop cannot be formed. Even around the charges or through the triangle. The only correct option is C. Fields are flowing out. They are repelling each other. They are as if diverging from each other. If you remember the simulation, when two positive charges were kept, they were diverging each other. So very important, guys. Just these simulations help you understand concepts better. These animations help you understand concepts better. But at the same time, see, option of method of elimination could have given this answer within few seconds. Just observe the closed loops. Closed loops cannot exist. It's simple. If I'm talking about positive, they would have some diverging field, right? They should all be diverging. So if we talk about this, it will be diverging. Nowhere there should be a closed loop. Alright, simple, easy. Let's get into the next one. Again a concept-based problem. Okay. Again a concept-based problem, again a JEE Advanced problem, again a simple one. A metallic solid sphere is placed on in a uniform electric field, and the lines of forces follow the. This time it's about lines of forces. So given option 1, 2, 3, 4, A, B, C, D. Forget that. Have a look at the lines. Try to think about it. So yeah, there are two principles involved in this. So think carefully. This looks okay. All right. 1, 2, 3, 4. Have a look at the field lines and try to guess the answer, guys. It's simple. Trust me, it's very simple. Okay, I'll tell you what is the concept behind it. This is a very simple problem. Okay, metallic solid sphere is placed in an electric field. Hi Yadav, hi Divya, hi Jeevan, hi Osho Rishi, hi everyone. Good evening, and get started with it. Any guesses? Any guesses, guys? Any guesses? All right. No, why two? Hi, round to hell. Hi. So what it should be? First of all, two rules. Rule number 1, fields cannot pass no. Okay, in that case, it's not flowing. Okay, it looks as if it's diverging, right? Yeah. Fields cannot pass through conductor. Rule number 1. These are like, universal law kind of things. Okay. Next is fields force lines. Same thing. Electrostatic force lines, fields, same thing. Try to think about it. Fields are supposed to be perpendicular. What is this field lines? This is the field applied on conductor. Okay, supposed to be perpendicular to the conductor surface. Right? These two things are like universal laws. You'll also understand why. One is wrong. Actually, one shows as if the fields are not passing, but what is going wrong with this? Let's use two colors to understand. Let's do a thing. Look more interesting. So I'm going to give a red color for fields cannot pass through conductor, and I'm going to give a blue color where fields are supposed to be perpendicular. And whenever this is violated, I'm going to cross them. Okay. So fields are supposed to be perpendicular, not perpendicular, even though fields are not passing inside. Option number 2. It looks as if fields are passing inside, or again they're not perpendicular as well. Okay, so let's cross it twice. Okay, and they are supposed to be in radial direction, right? Perpendicular means. Again, let's cross it twice because fields appear to be passing through the conductor. This is maybe passing along the surface of the conductor, or maybe outside the conductor, is still not perpendicular. So which should be the correct one? It should be 4, where fields are not passing through the conductor, or the force lines or electrostatic force lines are not passing through the conductor. So it follows both rule 1 and 2. All right, it's not passing through the conductor, it's perpendicular as well. Important basic concepts too. Important basic. So let's understand why is this true. And so first of all, you need to understand electric field inside the conductor will always be zero. If you get a charge over here, then only it is possible. See, electromagnetic waves cannot pass inside. Simple thing. Why and all, there are many ways to justify it, but you know what? This is like a universal thing. Second, to stay in electrostatic equilibrium, the fields have to be perpendicular to the conductor. It has to be perpendicular to conductor surface for charge. See, this is not, these currents cannot, these currents can flow, but in isolated conductors, there aren't going to be any active currents. If fields are going to be also along the tangential direction, probably, your charges have to move in whatever fashion it is, but they will be producing some currents. And that is not true though. They must be in electrostatic equilibrium. Hence, charges actually, first of all, charges always accumulate on the surface of the conductor. The thing is, they will be always perpendicular. The charges don't move, they will stay in electrostatic equilibrium. Alright. Simple, easy, intuitive. Alright, I hope you understood the point. Don't worry if you didn't get it. This is just basic concept. We just understood about fields. We didn't talk about it. I got it intentionally so that you understand this point, because this will be useful when we start doing all this mathematical kind of. So we are done with fields. You're done with everything. Now let's get started with a very interesting problem. Alright. So yes, now we are going to talk about today we will be primarily dealing with uniform distribution of charges. We will be soon also picking up few problems around non-uniform distribution of charges. So get started on this. So a charge plus Q is uniformly distributed along a length L. So along all this length, some charge Q has been distributed, and then electric field magnitude at point P is going to be how much? Which is the distance d from this rod, sort of a rod. Generally you see questions like rod, etc. from the charge distribution. Try to work around it. At least try to guess the method. So how would you work around it? So this is a simple one, and see, we are starting with a very basic problem. This is actually a basic problem. Don't worry if you are new to it, it's not a basic problem. But if you are already accustomed to it, this is a basic problem for you. But this is a standardized method. That's it. If you understood this method, just any kind of problem is easy. Okay. In the rest of them, we have to deduce the vector components, cancel the vector components, or maybe add the vector components and more. That is it. Okay. I'll get started on this. So there is a plus Q charge that is uniformly distributed along a length L. Then the electric field magnitude at point P at distance d from the charge distribution. Okay, you can't say there is a point charge. It's not a point charge, and if this d distance was infinite, maybe there's a point charge. You don't have to think very hard. It's kq by r square, or kq by d square in this case. Okay, but anyway, one such option is not given to. Hi Osho Rishi, hi. Get started on this problem. It's going to be super interesting. Right? I'll do a thing. I'll slowly get started. You can understand the problem. Very standard thing to do. Sometimes, plus Q is not given. A quantity like lambda would be given, which is nothing but linear charge density. This is the key to the problem. Once you do this, everything else is easy. Hi Aradhya, hi. Hello students, hello, good evening. Get started on the problem. And if you are attending it live, also to complete rest of the parts. They're very important. Okay. We discussed a couple of JEE advanced problems. So first of all, in this case, it's a uniform. If it's not uniformly distributed charge, lambda's function will be given to you. Lambda, I'm going to define a new quantity until now, which we haven't dealt in electrostatics, which is going to be lambda. What is the value of lambda? Going to be in this case Q by L, which is going to be linear charge density. You will see linear charge density. aerial charge density or surface charge density or volumetric charge density. Volumetric charge density should not come up, but maybe in insulators it is possible. Okay, linear charge density. All right, that is it. Okay, this is the basic thing. So as usual, we would take up a small elemental area like how we used to do even in the mechanics. If you remember, while calculating a moment of inertia, etc., you must have done this integration. Not, this is like also an awesome add-on lecture for you. We're not going to do moment of inertia, don't worry about it. This is dx. I'm going to call this element as dx. What is the charge present in it? dq. How much is that going to be? Lambda into dx. Right? Now the thing is, through this entire rod, it's uniformly distributed. So if I take any other element dx, it's going to have dq as lambda into dx. But the thing is, the distance is varying. This distance is somewhat, something like maybe like L plus D or nearby L plus D. This is somewhere near L by 2 plus D. Okay, just for your understanding. So the distance is varying. Hence, we would have to integrate for each elemental charge. And I'm just erasing this part. Now, we need to integrate for each elemental charge. First of all, let's analyze. Let's say this is at a distance x here. Okay, that means it is at a distance x plus d from d. Right? Okay, let's do a thing. Let's call this entire thing as x. Okay, we can substitute the value of d later on. Let's say this is a distance x. Okay, I know generally you would like to call this as distance x, but for now just imagine this as like distance x. It does not change anything. We will substitute the limits from what x is equal to d plus d to l. Okay, it's going from d to d to l. If you notice the limits, x is going from d to d plus l. Right? This elemental charge over here on this corner is at a distance d plus l. How many good question though, Oshorishi. So like how many days has it been since you haven't started preparing, or like haven't you prepared anything, or you're asking for some of your friends? What is the thing? Just a moment, I think flip the page. So yeah, like how many days is left for your JEE preparation? I got your question. You're asking me, is it possible to still crack JEE? And I believe the way you solve the questions, you are well accustomed with the kind of concepts. You haven't started preparing means how many days do you have, and what is your target? That also matters. So this end is at a distance d plus of l. Okay. This last elemental charge on this, uniformly distributed charge rod is at d plus of l, and this is at a distance d. So x is varying from d plus d to d plus l, right? Okay. So let's call field due to one of this elemental charges dE. Typically, this is what we do due to dq. Imagine this dx. Forget both of this dx. We'll give like a different color to this. If this is the thing, let's take this up. Something like blue color. Now this element is unique element. This looks like a unique element. We are talking about this unique. Like dx. Okay, this is dq. This dx has dq charge, which is nothing but lambda into dx. What is lambda? Linear charge density, which is nothing but q by l. We'll substitute this at there. This is going to be okay. Yeah, integrated. Yeah. Yeah, oh, sure. You can. I've asked you a couple of questions. You can get back to the questions. I'll be able to answer you. Probably it is possible, students. But if you are really targeting for the February session, try to also try to keep in your mind that you're preparing for the next session. That would help you better. Ultimately, a percentile, the best of the percentile, is going to matter. Okay. So I'm talking about field due to that blue color element, which is DE. Okay, which is going to be KQ by R square. Okay, K into lambda dx by how much distance it is at? X distance, x square. Okay. Now the thing is, you need to integrate it. Like what one of the students is saying, you need to integrate this to find out total field. Okay, total field or net field at the point D due to this uniform charge distribution is going to be integration of D, and this is going to be integration of K into lambda D x divided by x square. So this lambda into dq, what is this? Lambda into dx, kq by r square is what I have written, right? This is nothing but, okay, this is what you need to do. And what would be the range? Range would be from d to d plus of, simple integration is very simple, 1 by x square dx by 1 by x square, k lambda constant, k and lambda are constant. Let me take it on the next page. So we have this expression now to find out E net at point D, going to be integration of L to DL lambda into dx divided by x square to k. K lambda constant, we can take it out. K into lambda integration of dx by x square. Okay, let's first of all integrate and then substitute the range. So k into lambda minus 1 by x. Okay, minus of 1 by x. Right, that what is the range, guys? Range is d to d plus l. And yes, now if you're thinking minus 1 by x, don't worry, on the denominator it is d plus l. Anyway, greater value has to come on the subtract. I mean, like, greater value means in the range, among the range, the greater value has to come on the subtract. So this is going to be how much? KQ, sorry, K lambda in this case, linear charge density, guys, a new term, but this is a term that you need to get accustomed to. 1 by D minus of D plus of L. Okay, how much does that give you? K lambda into L into D plus L. Further simplify it. Just simplifying this E net at D, you can write it down as E net at a distance D as a function of D. It's a function of D, right? It's just substituting the value of D. If it's 2D, it's going to become 2D 2dx. So this is going to become what? K into lambda. We got a value of K to lambda into L. And what was Q? Q was nothing but lambda by L, rather Q by L is equal to. This is just Q. Okay. K into lambda into L divided by D into D plus L. Once verify with your dimensional analysis this is true, but that might be useful for your exams. So this is KQ divided by D into D plus of L. Alright. Easy. Same concept, any given problem, it is the same concept. I'll tell you what needs to be done if there are some variations. We'll discuss about the variations. Typically, a lot of your electrostatic lectures are going to be deriving the field, but you need to practice it. If you don't practice it, guys, it's going to be, it's not a complex topic. But if you're not going to practice it, it will ultimately look like it's a complex topic. There are a few complex concepts because every concept that is new to us is complex. But At the same time, you know that you need to agree to whatever is given, at least in your syllabus, even if you have doubts about it, and as well as any scientific thing, and then proceed with any sort of your thesis. Alright, simple. Alright, science problem. Anyway. So the answer should be kq by d square divided by d dl. Easy, simple, really simple. Let's get into the next problem. I think this is clear, guys. I think there should not be any doubt. Okay, this is a very simple problem. Next is again a charge distribution on a uniform sort of, it can be, they will say it as like a wire, rod, etc., or generally wire, rod, or along a length. Generally speaking, I've taken it as, a charge of plus q is uniformly distributed along a length L in this case. Then there is a length L, guys. If it's not visible, there is an L over here. This is of L, okay. And then the electric field magnitude at point P. Now this point P is, at a perpendicular, if you draw, it's not in the same line, but rather it's out of that line. Okay, it can exist anywhere in the space, but for now we are going to assume that, if I draw a perpendicular, it's going to be a perpendicular bisector. What do I mean by perpendicular bisector? It exactly dissects the rod into two, L by 2, L by 2. Okay, later on we'll also understand rest of the cases, but for now let's get started with L by 2, L by 2. Okay, so now this point is somewhere at a distance A from the rod, at a perpendicular distance A from the rod, and now you need to find out what is the field due to this. Simple, guys. Simple. True, really true. Theoryzilla, yeah. True, totally true. 12th class physics is you already got accustomed to many of the theories. You already got into the habit of admitting things. It's generally 12th class physics is a lot easier, less time consuming compared to 11th class. Okay, actually 11th class physics only you're covering few topics. In 12th class, it's not D, it's A. Oh, you mean the answer is D? Let me think about it. I think no. Check it out again. Check it out again. Maybe you approach the answer, but maybe you're missing something. Just notice B and D. Do you see some similarity? Or are you missing something? I need to solve it as well. Okay. Alright, let's get into the problem then. Simple problem, same concept, no difference. But let me tell you something amazing about this problem. Here it is length L by 2. I'm just taking, I'm just making this entire position. I've just, rotated this image by 90 degrees just to understand it better. So this is L by 2, this is L by 2. Now let's take an elemental area over here. Okay. Now this elemental area, this positive charge, if it's negative charge, is going to pull it towards itself. This positive charge, this will be like, not this, but other. Something really good about it. Line joining these two charges, there would be a field at this point. Whatever it is, okay. And we can take another symmetrical line over here. Okay, we can take another symmetrical, like line of charge over here. Let's say this is at a distance x from this point, midpoint. This is midpoint. It's at a distance x. Some techniques like what we discussed, during point charge sessions. How do you typically work on this? There will be similar techniques involved in this. Okay, this is only possible if it is, at the midpoint. This P is at the midpoint. The perpendicular from the P is at the midpoint. Okay. Now again, you join this line. This is also at distance x from L by 2. Okay. So the thing is, if this is R, this is also R. Okay. If you noticed it, let's call this as, this perpendicular. If you notice from this field perspective, this is perpendicular field, and this is for the charge over here, and similarly the charge over here would have a perpendicular. What would happen? Both of them would cancel out, right? Same charge, lambda into dx. Again we are going to do the same thing, lambda into dx. Your charge, total charge is q, your linear charge density is q by L, and what is your dq at any small element dx? Your dq is going to be lambda into dx, right, for elemental dx. So now in this case, the perpendicular fields are cancelled out, only parallel fields would. Alright. So what do you typically do in this case is, I hope you understood that point. So we are only concerned about parallel fields. I think this is clear, huh? Let's move on to the next thing, because there are multiple mathematical manipulations in this case we need to do. I'm erasing everything. I'll just write down this point. Lambda is equal to q by L. Okay. And for any small element, etc., you would write it down as, maybe at some point of time, if you are very good in memorizing, please do memorize it. Okay. I typically don't recommend, but I would typically recommend, but I wouldn't typically recommend to students who get confused. Okay. I'm not very good at memorizing things, so I don't recommend. So we need to only think about one part of the entire thing, that is going to be the perpendicular, the parallel fields. Okay, along perpendicular to the rod, you can say. Okay, parallel to the rod fields do not exist. Okay, often sometimes what you can have over here is, here it would be like negative, negative, negative. That is also possible, guys. So think accordingly. Okay, try to understand the concepts. Try to understand the concepts. There can be very easy questions in your JEE Advanced, JEE Mains from this kind of topic, because they know integration is going to take a lot of time. They may not necessarily give you, expression based questions are very less than JEE Advanced, if you know, even in JEE Mains. Try to understand the concept. It can be anywhere around, small concepts around there. This is angle theta. I'm going to call this as angle theta. Okay. Now what is this theta equivalent to? If this is x, and we need, just extending this line, we need only field along this line. Okay, let's later on think about theta. Okay, this theta will go from some like 0 to some like tan inverse of L by 2 divided by a. So forget that point. For now, just assume this to be theta. This theta is varying. Okay, for some distance over here, this theta is different. This is something like theta plus theta delta, or you can say theta 2, etc. Okay. Now at this theta, at an elemental x, I'm calculating the field, and we know this field parallel to the rod does not exist anymore, or perpendicular field does not exist. Whatever it is, for this field it is perpendicular, for this it is parallel. Okay. We are accustomed that way, but anyway, parallel to the rod, that does not exist. Now let this exist. How much is this? This is going to be, if this entire field we call it to be dE due to dx at some distance x, this is dx, element is dx, and what is the charge? Charge is going to be dq lambda into dx. Not worried about that too. We are worried about dE. This is going to be dE cos theta. Alright, d sin theta cancelled out. If not, you will take dE sin theta and they would be subtracted from one another. Do remember that. d cos theta adds up. d sin theta gets subtracted. But anyway, once you substitute negative value for theta, you will get both of them. Simple, guys. Simple. So now dE is how much? You can say now Now we are not worried about DE, but rather worried about D cos theta, because D sin theta is cancelled out in this case since it's symmetrical point. Okay, and this P is at a symmetrical. All right. So this is going to be lambda into dx dq. Okay, this dq by r square. This r, if I'm going to call this distance as r, let's do a thing. All right. What am I going to do is change the color a little bit for a better understanding. Now we are only going to say that we are talking about DE, but we are ignoring DE sin theta, since DE sin theta gets cancelled out. The perpendicular or the field parallel to the rod gets cancelled out. We are only talking about DE cos theta. It's not equal to, you can say DE implies it's DE cos theta. And how much is DE cos theta? DE cos theta is nothing but lambda into dx charge, or let's do it itself. K into dq by r square, which is nothing but K into lambda dx by r square. Now students, one very important thing is, you know what, some of the mathematical manipulations throughout this electrostatics, at least you need to remember. You can't remember the expressions. If you remember the expressions, if you don't remember the mathematical manipulations, that is more harmful. But throughout this chapter, one thing that I want to remind you, see, this is coming from all the mistakes that I made or that I observed my friends made, something like that. Mathematical manipulations, something that you want to remember. At the moment, it seems like, you know what, these mathematical manipulations are irrelevant, but at the exam they would be useful. Really useful. If you can't at all remember the expression, it is possible, but at least mathematical manipulations are something that you remember. Okay. Now the thing is, what is R? R, let's express it in terms of you know, x. It's going to be tan theta is equal to x by r. So r is equal to x tan theta. This is fine. Okay, one more important thing. We forgot cos theta. Okay, have been a cos theta. Okay, let's get it down. Let's write down the cos theta. We're only dealing with cos theta. Okay, for sin theta, nothing would change except for the fact it's going to be sin theta. Couple of things that you want to maybe substitute, okay, as we move along. Write it down over here since we need some space to substitute. K into lambda dx by r square cos theta. This is the final field that will be left over. Okay. Now the other mathematical manipulation is going to be for dx. Typical mathematical manipulation you will observe for many of the problems that you will be doing is dx. Okay, dx we want to calculate in terms of theta. All right, and we do have a standardized value to do that. Which should that one be? Okay, I'm sorry guys, so this should have been r should have been 1 plus sorry, it's not tan theta. B x by r would give you what? X by r would give you, I'm trying to substitute x in terms of r. This would be, let's write down r as what, you know, simply going to be even a simpler method, I guess. Let's do a thing. Let's write it down in a simpler terms. That is going to be according to me, r would be simpler if I just wrote it down as x square plus a. Okay, a is constant. Okay, a is constant. In any case, r and x are changing. Better to express in terms of a. Now the other thing is you want to also substitute dx. So how much is x? X is equal to x by a is tan theta, right? And x is a tan theta. and dx would be a sec square theta d theta, right? Tan theta, you can just differentiate it. If you can find out as 6. So you can also take cos theta, sin theta by cos theta and do it. Alright. And let's do a thing. Let's write down the same kind of expression, maybe with, take up a different color and do this. R square is equal to x square plus a square, which is nothing but from this expression, going to write it down as a tan theta whole square plus of a square. How much is that going to be? A square into 1 plus tan theta whole square. What is 1 plus tan theta whole square? 1 plus sin square divided by cos square. Sin square divided by cos square, okay, which is going to yield 1 by cos square, I believe. Don't you think so? 1 plus tan square plus 1 plus tan square is nothing but 1 plus sin square plus divided by cos square. Take up the cos square over here. Cos square plus sin square 1 by cos square, which is going to be nothing but a square sec square again. Okay, so if you substitute this value that we have just derived this from the mathematical manipulation, so yes, I think this is all visible. These are very important mathematical manipulations. So you need to note it down. Okay, work along. So this is going to be k into k is constant, lambda is constant. Now we need to work around dx by r square. Alright, dx by r square, dx substituted, that's going to give us a sec square d theta. Why we are bringing it in theta? Because it's easier, guys. No other reason. Okay. Divided by a square sec square, simply. This is 1 by cos square. A square into 1 by cos square. You can do that, okay? Simple. Alright, I think this is all fine. Into cos theta. Don't forget the cos theta. So sec square cancel. 1a would get cancelled out. What are we getting? K lambda divided by a into cos theta. And this is what? dE. We can say this as dEx. If you are going to call this as dEx, this dEy, dx gets cancelled out. Maybe dE. There are some reasons why I am saying dEy, because when we derive for a non-symmetrical surface, it's going to be C. No, not C. Work it. Small mistake has been really good, but try to work around it again. Divya, good, really good, really good. So what is your dEy? dEy is nothing but dE cos theta. And dE cos theta, how much did we get it as? From this, we got it as k lambda by a. After cancelling out everything, we just got k lambda a cos theta d theta, something maybe. Okay, something maybe you can, directly write it down in future. A standardized thing. Similarly, over there, what would you get? For dE x, you will get it as k lambda by a sin theta d theta. But we are not dealing with the parallel component, we are just dealing with the perpendicular component, or this component along y direction. I know this looks like this is x, but we have just rotated the axis, so don't worry about it. For now, you can, even if you want, you can write it down as dx. Okay. So whatever, but this does not matter. This you have to know that perpendicular to the lot, it will come out as k lambda for uniform charge distribution. It will come out as k lambda by a cos theta d. Okay, and this theta varies from. One thing we can do is we can write it as 2 dy and just calculate it from from 0 to theta, right? Total field E total, what are we going to do? We are going to write it down as 2DEY. How much is this? From 0 to some, let's call this as, for now, already we are dealing with phi, so let's call this as phi. Let's later on define this phi. That makes our life easy. Let's call this as phi. Total angle is phi. Okay, else you can just, do one more thing, that is, integrating from, calling one side as minus phi and integrating it from minus phi to plus phi. But this is rather, little bit less calculation. Okay, and more, easier. So k lambda by a, this is E total 2E dy, and this time you are going to integrate it, right? Without integration, this is not possible. Integration, and integration d theta. What would be the range, guys? Would be from 0 to 5, right? Simple, really simple. Don't worry about it. Now cos theta integration sin theta. Differentiate sin theta, cos theta. Okay. 2k lambda a into sin theta, and the range should vary from only theta is variable. That's the beauty of it. Phi to 0. So it's going to be 2k lambda a. So obviously there should be a 2 on the numerator. That's the hint. Sin phi. Alright. I believe everything is correct up until now. Let's move on then. So what is sin phi, guys? This is L by 2, right? This is phi. Sin phi is going to be opposite by radius. Opposite by radius, or opposite by hypotenuse. How much is opposite? Opposite is L by 2. And how much is your L by 2 whole square plus a square? L by 2 whole square plus a square. Okay. So the total field is nothing but as simple as 2 into k into lambda. And you may want to also substitute the value of L. Okay. L by 2. Lambda into L is nothing but Q, simple. Okay, divided by under root of L by 2 whole square plus of a square, which is nothing but 2 gets cancelled, or ultimately you get a 2 on the top. Okay, you can look after the math. Lambda into L, how much? We just did it. Q, 2kq. Okay, this 2 gets cancelled out, but I'm going to bring this 2 square on the numerator. Don't worry about it. So that ultimately you will be having a 2 on the numerator. That is going to be like L square plus 4a square. Simple, isn't it? That is it. That is it, guys. That is it. That is the net field. But this case was a symmetrical case. Easy one. Alright, I believe this is clear. I'll come back to this point again. So what did we do is we standardize things in terms of theta and d theta to solve this problem quickly, and in fact that is the easiest way to do it. So initially we understood one thing. This was a symmetrical case. Even if not a symmetrical case, you would still do the same thing. Okay, just a second, guys. Just a moment. All right. So the thing is, let's have a look at the problem. So the thing is, you know what? First of all, you want to understand. you probably already understood few things. One is going to be you are taking an elemental area and calculating the field at some point. Since this was a symmetrical charge distribution across P, you draw a perpendicular from the point P. Here it's going to be L by 2, here it's going to be L by 2. All this fields along, x direction. In this case, it's maybe like y direction. In this direction, it's getting cancelled. Okay, simple. Let's come to the next thing. Only the fields will exist in the direction perpendicular to the rod. That's one thing. And we want to standardize in theta, saying that it's going to vary from theta from 0 to theta. Okay, going to vary from 0 to theta. Okay, and this component would be dE cos theta. And what I'm saying is net field is always going to be dE cos theta. You can integrate it from minus theta to theta. That also something that you can do. That is also something that you can do, but we did it in a different way. It would be like dE cos theta. Net field is dE cos theta in this case. Else it would be dE cos theta. Maybe you will have to give an this is going to be x, maybe y cap in our case, actually according to our question, maybe, but in this picture it's like x cap and y cap. You'll be giving two different directions, right? So that is one thing. And the other thing is going to be this is the net field, and the other thing is going to be standardizing in terms of theta. Okay, hi Sahasra, hi. Other thing is writing it down in terms of theta, guys. Already got a cos theta. Probably you want to write it down either in terms of x and integrate it, because we ultimately are going to replace dq is equal to lambda into dx. For this elemental area charge is going to be dq, which is going to be nothing but lambda into dx. Or the easier thing is dealing with thetas. Okay, angles. I'll tell you why. In this case, it's especially very easy. And in many cases, you'll find this is going to be an easier thing. Okay, so first of all, I wrote down the value of r, which is nothing but under root of x square plus a square, and then I said that x by a is tan theta. If this is theta, okay, if this is theta, x by a, x is a variable, a is a constant thing, x by a is tan theta. I'm saying that x is nothing but a tan theta. So dx is going to be a sec square d theta, differentiation of sin theta divided by cos theta. You do that as well, you'll get as sec theta d theta. And r square is x square plus a square. What I said is, like, what I did is just substituted this x as a tan theta. So it's going to be a tan theta square plus a square, which is nothing but a square into 1 plus tan theta whole square, a taken out as common. And tan theta square, 1 plus tan theta square, what it is? 1 plus sin square divided by cos square. So cos square plus sin square 1, and divided by cos square, which is going to be, okay. So if you substitute it, you will get something, a very standard form, which is going to be k lambda into, so initially let's substitute it, k lambda, this I have taken out, okay. And the next thing is going to be dx substitution, which is nothing but a sec square d theta, okay, a sec square d theta, and there would be a cos theta. In the denominator, what did we have? A square sec square theta, sec square cancelled out, one a cancels out, and there would be cos theta d theta. And if you similarly do for the line along this place where it's not a symmetrical distribution, you will get it as for this side, you'll get it as k lambda by a d theta sin theta. I will do that, don't worry, it's going to be a short process. Okay, this is clear? Okay, good. So anyway, I'll complete it. We have just started it. So you know what, sometimes it's not that clear to maybe everyone. So that way I wrote it as, this thing I wrote it as DEY. Typically in our case this is DEX. I wrote it as DEY. Let's not do that thing. Maybe this is confusing. Just take off this DEY. This is, let's say, DE perpendicular to the rod or something. That is going to be DE cos theta, k lambda by a cos theta d theta. This should be clear, guys. This is a standardized form. For the other one, k lambda by a sin theta d theta. What is the total field now? 2DEY. Okay, 2 dEy. And guys, do remember one more thing. You can either do the integration from 0 to 5 as I did it in the case, as I told you, here I am going to see two fields, which is going to be 2 dE cos theta. That's good, you understood it. Very good, very good. Okay. So 2 dEy, which is nothing but 2k lambda by a cos theta d theta. Okay, but maybe in the asymmetrical cases, you don't want to do this. Okay, we'll discuss about asymmetrical cases as well. So what you want to do is maybe just integrate it from some minus theta, if you take it as a midpoint to be some theta, or this point to be 0, however it is given in the question. You want to take this to be minus 5 and integrate. Instead of 2, there would be just dEy. Okay, instead of 2, there would be just dEy if I did it from minus 5 to 5. If it's unsymmetrical from some, alpha to beta, then you just write it down as dEy. You will similarly do for dx, and you write it as, minus alpha to beta. There will not be a 2. K lambda by a cos theta d theta. So integrate this, you will get it as 2k lambda by a sin phi. In this case, what is sin phi? Typically you have to do this. Sin phi in this case is opposite by this hypotenuse, which is going to be L by 2 divided by under root L by 2 whole square plus a square. Substitute it, you will get the answer. The answer is going to be 2k cube L square plus 4a square. Good. Understood it? Very good. 2k cube. There would be L as well. Okay. I think we are missing. Be an A. Sorry guys. There should be an A. There should be a A. There should be a A. So it would not be the option is wrong. There should be an A. I tried framing the options. There should be an A. Very good, very good. Okay. Don't miss out. Anyway, we'll standardize this thing. Don't worry about it. There should be an A, there should be A, there should be A, there should be A. Let's start standardizing things. Okay, this problem is over. So let's say now we are going to standardize it. What I'm saying is, right now it's not on some perpendicular bisector, but rather this is forming some angle alpha, beta. See? And now you'll understand it better if you haven't understood it. Until now, this is going to be super easy, so don't worry about it. Okay. This is alpha, this is beta. Just saying this alpha. So this is going to be like from this point, I'm going to assume this point is 0. Because I'm saying this is all x, x and x, same x. Now in this case, what I'm saying is I'll calculate the individual fields. I can't say everything would get cancelled out. The best thing to do is calculate individual fields. And you know what? Integrate it from minus alpha to beta. Okay? Integrate it from minus alpha to beta. Okay. Now the thing is, this is only applicable in the case of uniform charge distribution, else a function of lambda will be given to you. Okay, a function of lambda will be given to you. Taking an element dx again, didn't understand it last time, don't worry. This is going to have charge dq, which is nothing but lambda into dx, which is going to be, okay, this dq. Okay, and what is lambda is going to be? Lambda is going to be, let's say the rod's length is L, then lambda is going to be q by L. Okay, we'll leave it in the form of lambda. Maybe if you want to remember it, you can remember. Okay, don't forget to substitute lambda is equal to q by L in the final equation. Now, first of all, the thing is, it's not at the perpendicular bisector. It's not symmetrically dividing this, uniform distribution of line charge or rod charge, whatever it is. then in this case this is probably not even, you know, like but you're dropping a perpendicular. Okay, anyway, dropping a perpendicular. So in this case, you know what, the fields would not cancel out. You would have to calculate the fields DEX component and DEY component for the individual. What I'm going to do is, it's simple, guys. It's very simple. We did all the mathematical manipulations that is required to solve it. Hence, this is super simple. Don't worry about it. At this point, let's say this is the direction of the field, some DE field, and this can be at this angle, at this point X. Let's take a theta. Okay. Let's take a theta. Of course, this way, you know, when you go on this side of the point, these charges, some of the part is going to eat up this field. But you know what? Ultimately, there would be either a charge imbalance. I mean, like you know, it's not symmetrically distributed. Hence, field would exist on this side as well and this side. So it's better off, you know, let's not do that thing. Maybe in some cases you want to apply that small techniques, just if, you know, very small things are asked. We'll also have a look at a few such cases of, you know, like questions. Okay, this is going to be some DE. And two components, if I'm saying this is the x-axis and this is the y-axis, I'm going to define two axes. This is going to be some theta. Theta varies from minus alpha to beta. This should be clear, guys. Should be crystal clear. Okay, this is theta, and that's it. So this is going to be this component along this direction is going to be d cos theta. Anyway, you understood this is also theta, right? So I'm erasing the theta part and write it down. Can't write it down, don't worry. So this is 90 minus theta. So this is going to be de cos theta, and this is going to be de sin theta. All right. Hi Ajay. Hi. Good evening. All right. Now let's do a thing. Let's calculate. You know what? First of all, this is where your theta lies. We deal with. So let's do a thing. This is going to be no 2d cos theta etc. So I'm going to write down two components. One is going to be dx. So your you know, probably your field consists. DE fields consist of two things. One is DE x cap plus DE x of x cap and DE y of y cap, right? Or I cap, j cap, whatever you like to put it as. You can use that that kind of annotations. In this case, I'm just using x cap and y cap. One is along x. This is clear. Now we will have to deal with each individual thing. Okay. Each individual thing, I'll show you the mathematical manipulations very shortly. Dx, what is the value? It's going to be de sin theta, and dy is going to be de cos theta. Okay, and what is de? De is nothing but okay. D is going to be, writing down DE is going to be dq k into dq by r square. Okay, we'll substitute the value and do the mathematical manipulations on the next page. Then we'll get started with one of them for DE and just substitute the value of DE. We're just calling DE some quantity, guys. Okay, some then let's keep this as d total, and this is some de. Okay, some de that we haven't defined yet. Okay, some de that we are going to calculate. Same kind of de exists. This is de sin theta, this is de cos theta. Probably this de only added a vector on the top, but let's keep it as a different, because d is some scalar quantity that we are going to calculate. So do practice it, students. Do work along with me. That's very important. So we have taken a case where it is going to be theta. Right, this is theta. This is x, right? And this is a. All right. Now the thing is, tan theta is equal to x by a. Same mathematical manipulation, students. If you didn't understand it, it's tough. Okay, but if you remember it and if you understand it, it's easy. And I assume most of you do understand it. Okay. So as x by a is equal to tan theta, so x is equal to a tan theta. Easy up until here. Now d, as we defined, is what? So next thing is going to be, you know what it is. You have to take dx and try to find it in terms of theta, which is going to be a sec square d theta. Simple, right? These two things we wrote down, right? What is your d? D is going to be k into dq by x square, r square, I'm sorry, r square, r square. Going to be r square. Okay, this is r. How much is r? R is under root of x square plus a square. Substitute everything. It's simple. And let me do a thing. We can calculate r square simply from here. R square is equal to x square plus a square, which is going to be how much? A square tan square theta plus a square. As we saw earlier, this is nothing but a square sec square. How did we get this? A square, take it out as common, it is 1 plus tan square, which is going to be sin square plus cos square divided by cos square. Sin plus square plus cos square is 1. Just substitute these values. These are some things that these are at least some steps that you want to probably not memorize but understand, and you know, get the sort of aptitude or the intuition to approach the problem. Simple. All right. Now the thing is, this is how much? K into dq. dq is how much? As we said earlier, at for this elemental dx, it's going to be elemental dx. It's going to be dq is lambda dx. You know what is lambda? Q by L. We are not going to substitute lambda for now. Later on, but maybe not. But at least probably you know what is lambda. This is going to be lambda into dx, and this is like a square sec square. Now let's substitute the value of dx. It's nothing but a sec square d theta, a sec square d theta divided by a square sec square. Sec square cancel, a cancel. There's a d theta. If you haven't observed it, I'll do a thing. Can't write it anywhere. That's okay. There's a d theta over here, right? So d is how much? K lambda. Something very interesting, guys. K lambda d theta divided by a. Very easy to remember, right? K lambda by a into d theta. So deriving it will take a lot of time. It's something easy to remember. What will you do? Integrate. Simple, guys. Simple. So integrate it from minus alpha to beta for both of them. Okay. So let's do, first of all, you know what, dx. So we will carry out the value and write it down over here. Our d is how much? Like we got it as k into lambda by a into d theta. Instead of dx, it's d theta, right? Makes sense? Easy? All right. Let's do a thing now. Now we have two components going to be along x direction. This is going to be This is theta. We had a theta over here, and theta varies from alpha to beta. Theta as well. Okay, this is theta. This is x component d sine theta. dE sine theta, you want to integrate it to find out Ex. It is going to be dEx. Alright, and simple. Substitute the value of dE. This k lambda A into d theta. Right? Simple to remember. And of course, if you want to derive it, you can derive it. But maybe, like, you want to maybe work only on integration part, a little bit of integration part. This is only possible because lambda can be, a non-uniform charge distribution in a question. Ultimately, you want to not, directly maybe remember this. All right. So yes, now it's really simple, guys. Ex is how much? Ex is going to be k, and this is from alpha or minus alpha to beta. Let's verify the value. It's going to be minus alpha to beta. We have taken it from minus alpha. This is somewhat like minus. So anyway, theta is going to vary from minus alpha to beta. Okay. This is going to be k lambda A divided by A. This is going to vary from minus alpha to beta. And once you integrate this cos theta, sin theta, d theta, integration cos theta, which is, so if you differentiate, so just a moment, differentiate cos theta, so this minus sin theta, alright? This minus cos theta, so this is minus cos theta. This minus cos theta, check it out whether it makes sense. This is minus alpha to beta, but that does not matter anyway, I guess. So it will be basically b, because minus of alpha is nothing but in cos case it's going to be just cos alpha. It's k lambda by A cos of beta minus cos of. Makes sense. There should be a negative sign. There should be subtraction of fields. So your Ex is actually going to be k lambda by A. Lambda is q by n. Cos beta minus cos x cap. You want to add another. Similarly, you will get sin alpha plus sin beta. Okay, we'll do that as well. Your dEy times no direction, guys, and we'll directly write down and integrate it. This is going to be from minus alpha to beta. Yes. Okay, this is going to be d. Okay, do it that way. Gets your memory or d, and this should be cos theta along y direction. Take down the notes, students. Very important. This is x, this is y. Okay. This is theta, this would be y, this would also be. This. So yes, that's the plus alpha. Yes, and d, if you remember, what was it? K lambda by d theta. K lambda by A into d theta. Right, so this is going to be cos theta d theta. There would have been k lambda by A into d theta. D theta is variable. Cos alpha integrated, you would get it as k lambda by A, this sin theta. Range is from minus alpha, beta, That would give you sine of beta minus of minus sine beta alpha, which is going to be sine of beta minus of sine of minus alpha, which is going to be sine of alpha plus beta. A lambda A sine of alpha plus sine of beta. But do remember, you can't add them both without a vector notation. So just throwing in the vector notation. Easy, simple. Let's write down the expression for net field. For the net field, so this after integration, I'm sorry. So this is after integration. Ey, just Ey, okay. Just to solve. Want to know what I was trying to write, what we were trying. All right. Anyway, this being said, students, a very simple thing. Electric field net should be both in x direction and y direction. K lambda by A would come out as common. You can write it down. You remember K lambda by A will, irrespective of anything, come out as common. We are only dealing with thetas in this case. So it is going to be sine of alpha plus of sine of beta into y cap, right, plus of cos of alpha or beta. Cos of, it should be beta, guys. Okay. By beta, because integration gave you negative, and that is also true. Just notice it. Notice the way we have done it. You can understand everything from this example. Maybe you want to write down this example. It's not something recommended to remember, but if you want to remember, you can remember. But something that you want to maybe like maybe keep in mind is nothing but simply resolving the components. How we did it? Simply this part. Standardize something simple, easy, sober. Okay. So yes, guys. So we derived something very interesting. From this, we will, we'll solve a very, very interesting problem. Okay. Until now, we are dealing with, finite length. Now let's do a thing. The Q charge is distributed over an infinite length. The question is about, you can solve the problem later on. I'll just quickly show you how to do this. A charge plus Q is uniformly distributed along an infinite length. Then the electric field at point P at a perpendicular distance A from the charge distribution. Take the perpendicular from the P on the charge distribution bisects the dot, creating an L by 2 over here, L by 2, but this is extending from minus infinite to infinite. This is extending from minus infinite to infinite. Right? How much is that? If it is extending from minus infinite to infinite, it would be a right angle. This is minus pi by 2 to pi by 2. And you remember this is bisecting. Simple question. Only one component will exist, that is going to be along this. So this is okay. This direction, sorry, along the y direction, which was we found out to be K lambda by A. Just substituting the value and showing you Ey is equal to K lambda by A into cos of alpha X wouldn't exist though, right? We did this out. Was this was by everything? Okay. We have to just substitute the value of alpha, right? We are not going to put it as minus alpha. Okay. Anyway, you can do the integration as well, but this is not minus alpha. Hence, I was just thinking, this was alpha. Why are we getting this? This is this we are not going to substitute as minus alpha. It will be pi by 2. Even though this is alpha case, this is sort of minus alpha. Alpha's absolute value is pi by 2. Right, and beta is like positive and pi by 2. We have only substituted the absolute value. This is going to be sine of alpha plus sine of beta. They're divided by 2 or something. I'm just doing it from the expression, guys. I'm not doing anything. It will be along y cap direction, and k lambda by a 1 and 1 is going to give us 2. Right, so it's going to 2k lambda by a y cap, and how much is this? 2k lambda q by l a y cap. Answer should be D. It's simple, very simple, guys. Very simple. Okay, I didn't actually, I made use of that expression, but you could have just substituted the value of D, which is nothing but k lambda by a d theta, and could have done it. Okay, ultimately it's going to be only you think about some angle, it's going to be like cos theta integrate sine theta. But once you start solving it, you substitute, you'll start solving it, it will be like sine beta, which is going to be sine pi by 2 minus of sine minus pi by 2. You'll get it as 1 minus of minus 1, so it will be 2. Don't worry about it. In that standardization, do remember it is from alpha to beta. There I will keep it as alpha. It's something that we can, it's minus alpha to beta, but yeah, I will do this. Easy, simple. Alright. Yes, we have something to do with ring, which will get started tomorrow. It's going to be super interesting, so stay tuned. Don't miss out on a single lecture, and you know what? It's rest is going to be super easy, and this is also easy. Don't worry, just go through it again if you didn't get it. And even that field lines concept, very important. Field lines, based on field lines, I've seen at least 6 to 7 problems in past JEE Advanced and JEE Mains. So understand field lines really well. Whichever format, whichever form it's possible, field flows from positive charge to negative charge can form only a loop if it is flowing from unlike charge. And from positive to negative to be. Number of field lines represents the strength of the field. It does not mean you are drawing 2 or 3 lines, does not mean, and on the other, if you're drawing 10 lines, it does not mean along the 10 lines field exists. But the 10 line represents that electric field. As that 4 line shows that it has a weaker magnitude. Both these charges will have their individual fields at any point in the space. And also at depth. Okay. That is it. Yeah, conductor does not allow any electric field or electrostatic force. Field lines or force lines to pass inside them should be perpendicular to the surface. Simple. Take down the notes. It will be really easy. I believe, rather than handing out notes, you should be making your own notes in electrostatics. Going through notes is not going to help you because you cannot memorize things, especially for JEE. You have to make your own, at least for electrostatics and mechanics. These are 2 topics where you don't want to be dependent to the greatest extent, maximum possible. If you have even noticed the questions, you can get the the feel of the questions, the type of the questions we are bringing up in the session. Okay. Alright, students. I'll anyway we'll take up rest of the problems. They're easy. These are like very easy problems, and we'll do this in the next class. We have a little bit more problems coming up for you, and they are going to be super interesting. Don't worry. So, and that being said, students, if you are on plus, enroll soon. We have just started with optics, started covering very interesting course. We have very interesting students on on this course, so you may want to check it out. Very interactive class, very conceptual, and also we are exploring many different ways to solve the problems. That is very awesome. very easy ways to solve the problem as well. So enroll to optics basics to advance on if you're on plus, and if you're planning to purchase subscription, enroll soon, guys. The course has been launched on 9th of October. It's a comprehensive course from basics to advanced, which includes both ray optics and wave optics, anywhere around 60 lectures. And the 60 lectures will be probably covering anywhere around 400 to 500 different model problems, etc. So it's going to be super extensive, super intensive, and also super interesting, and you may want to attend it, guys. It's a very interesting course. And do not forget to share the video, do not forget to like the video, do not forget to click on that subscribe button and bell notification. Guys, it's a free of cost initiative, so JEE English is a free of cost initiative, and you are getting quality content for free of cost. Okay, so yeah, so this is a free of cost initiative, so do share the video, like the video. Not only that, come regularly to the lectures, and also, guys, don't forget to share the video. And that being said, students, keep smiling. Don't forget to smile and work hard, and some smart ways are being taught to you in this class. So yes, achieve it by only not just working hard, but also by working smart. Acquire the knowledge and share it, guys. And that being said, if you're not yet on our Telegram channel, do get onto our Telegram channel soon, guys, and because you will get timely notifications on every such lecture happening on JEE English. And that does not only include JEE English based lectures. We also conduct lectures on Unacademy special app or learning app, and you can also check out those free of cost special sessions by getting onto our Telegram channel. And this link is available in the description box below. First of all, you need to download this app from the Google Play Store and App Store, and once you download the app, you can just type in JEE English to find us on. And we also keep posting you with all updates on strategy sessions, etc. And students, do check out the A to Z dimensions, units, dimensions, and measurements. A very interesting chapter, a very easy chapter, and a very scoring chapter, and a less time taking chapter. And typically you get 2 to 3 questions combined, JEE Mains and JEE Advanced. Something that you want to complete that takes very less time, very less efforts, and a very easy one. Yep. So it's available on Unacademy Learning app. So do check it out. It was conducted from 19th September to 22nd September. Back-to-back session is available on Unacademy Learning app, which is the most downloaded learning app. So do download the app. All you need to do is type in Unacademy on your Google Play Store and App Store, and the first search link is going to be your Unacademy Learning app. And guys, click on that install button, and we impact near about 7 million lives a day, and you are one among them. So do share the video, do download the app. Not only that, by downloading the app, you'll also get live notifications on the educators that you follow. That is one of the awesome things. It's a technologically equipped app, and not only that, we also have free of cost functionalities like live quizzes that happen every Tuesday, and these includes PYQs and many model problems that appear typically in your exam. So you may want to install that app. You don't want to wait for it. And that being said, students, if you're looking for a champion's tool for your JEE Mains and JEE Advanced preparation, we have the best one for you. We have the best one with the best educators across the nation for you. And when it comes to JEE Mains, we have legends like DC Pandey sir on this platform. And this is the best thing that you can have for your JEE Mains and JEE Advanced preparation. It comes not only with daily interactive classes with quality lectures, but with a planned and a structured program. So in this program, you will be typically getting prepared and trained for your JEE Mains and JEE Advanced to realize your dream of becoming your champion, or your a champion in JEE Mains and JEE Advanced. Guys, this is the best thing that you can have, that comes with live quizzes, like national level live quizzes and test series that you can attend from the best educators across the nation. Not only that, you can get your doubts cleared from the best educators across the nation. All you need to do is, click on the left hand top corner extension bar, choose IIT JEE as your goal. With that, you are getting prepared for both JEE Mains and JEE Advanced. You will enroll in the program accordingly, and then you'll click on the get subscription button. And one more important thing and a beautiful thing is, one subscription, unlimited access is what you gain with Unacademy subscription. So you can enroll to unlimited programs, but focus on few programs that can really help you excel in your exam. What do I mean by really excel is, if you focus on multiple programs at the same time, maybe not. So try to stick to one educator, try to follow the lectures. Not only that, try to enroll in the right kind of program meant for you, whether if it's meant for a droppers batch, whether it's meant, you have like like a numerous number of programs that have been floated. Just the last week we had 600 around programs for JEE Mains and JEE Advanced preparation. So you want to choose your program according to the target, and the price is also very reasonable, guys. It's only going to cost you 2,100 per month, less than 70 rupees a day. And this is typically meant for 9th, 10th and 11th class students. And guys, you can excel in your exam by choosing this Unacademy subscription, and you can apply Murli Live coupon to get the best discount on your subscription purchase. So yes, but you know what, we also have convenient payment mode for you, which takes away the burden of paying all the fee at once. You can choose our in-house pay in part options to split the payments into multiple parts. This takes away the burden of paying all the fee at once. Not only that, we also have no cost EMI, which also takes away the burden of paying all the fee at once. Yes, these are two interesting payment options for you. We also have traditional payment methods like debit card, credit card, UPI, etc. And that being said, if you're a dropper or long term, this might be the ideal program for you. You may want to choose a 12-month program. So you'll enroll in the program accordingly. There are droppers batches. There are dedicated programs for you from the best educators across the nation on an Unacademy subscription, and at a very reasonable price of less than 2,900. The price of 2,888 only. And how do you get to this price point? By applying Murli Live coupon. So apply the Murli Live coupon to avail the best discount on your subscription purchase, students. So this is going to be the best discount by applying Murli Live coupon. Yes. And students, that being said, do not forget to like the video. Do not forget to share the video. Stay tuned for more interesting lectures on electrostatics and more on JEE English. So click on that subscribe button. Click on the bell notification. See you in the next class. Take care. Stay safe. Bye-bye. And good night.